So I'm speaking of where to live on Mars. We have, well, first Pierre Brisson, maybe some don't know me. I am founder of the Mars Society Switzerland, and I have been, in my life I was a banker. But I have always been passionate about geology and natural and physical geography. So that's why I'm speaking of Mars geology and planetology. Well, where to live on Mars, that's a question we may ask, before going. And these are the constraints. Everybody, I think, would agree. Accessible water ice, altitude as low as possible, proximity to the equator, flatness of the ground. I go in the details. Water ice, of course, everybody knows about it, and we can use it for our own human life, and also to make propellants, as Robert Zubrin told us. Altitude as low as possible. Well, these are the altitude on Mars from minus 9,000 meters up to more than 21,000 meters. Well, in fact, we don't reach minus 9, but here we have the lowest, at the bottom, the lowest altitude which has been noted. It's 8,200, and we have 1,100 Pascal at that altitude in average. At zero datum, we have 610 Pascal. This is well known. It's a point of the 3 point of water of, I don't know what's the name in English, but it goes from well, the point where gas, liquid, and solid meet. And at 21,000 meters, we have only, that is summit of the Olympus Mons, we have only 30 Pascal. So really altitude is very important. Equator, this is also very important because we want to save energy, use as less energy as possible, and if we go too far, too up, too far, or to the south or to the north, then we have a very severe winter, and we have to spend a lot of energy. So we have to be as close to the equator as possible. And also, we have to, the advantage also is to have an equatorial rotation velocity, which otherwise we don't have, and for landing and for taking off, that's quite important. It helps. Temperature, I put the maximum. I should have put also the maximum at the second line, but maximum 20 degrees C in and maximums, that is the less we have. At most we have minus 33 degrees, but it can goes down to 120. Flatness, well, this is obvious also. To land, we need, to limit risk, we need this kind of landscape, which is nice anyway. Location. So here I have the possible location which have been considered. This is Elon Musk's choice. So we have to take it into consideration. This is in Arcadia, Arcadia Planitia. I don't know. Oh, here. I don't know. Well, Arcadia Planitia on the left, Pierre. You see.
Pierre, just here. Here.
Ah, okay. D'accord. Merci. Arcadia Planitia, you see. So this is a choice which I don't quite well understand, but its altitude is low, and and flatness. We have flatness, but it's really two-way north, because this is 50 degrees, 40 degrees. It's about 40 degrees, a little less than 40 degrees north, and it's a lot. So, but what is funny is that Elon Musk said that he had the idea after discussing with the author of the book from which the film The Martian was made. So Ridley Scott, yeah. So I don't think it's a very good reference, but anyway. Arcadia Planitia, this is one part of it, this is the other part of it. And this one is mountainous. Second possibility is Acidalia. Same latitude. The only point is that this is an interesting point to create habitat. Maybe there is also a lot of water underneath, because this, as you see, this is where the water coming from Valles Marineris, Ares Valles, and this one too, fluid. And this, there was a lot of current in that part, Crise Planitia, but reaching Acidalia Planitia, there was a lot of deposit, mud deposit, and the result is that we have mud volcanism. Mud volcanism, that is a detail. Mud volcanism, this is it. And of course, you can imagine that if there is still some water underneath, then we can also maybe bore or dig or excavate whatever to make habitat. It's rather small. It might be a few hundred meters in diameter. Noctis. Noctis, it is another point, interesting. This is where Pascal Lee found what they called the Noctis volcano. And there is a place here, which is Noctis Landing, where he said landing could be made. And another point also interesting is Relic Glacier, which is very close to this place, which is rather flat. The problem here is the altitude, because altitude is around zero. It's about, and also there is really, it's a really mountainous area. So, well, it might be interesting, but rather difficult. Another one is Utopia Planitia. Also, this is still in the 40s. Utopia Planitia is interesting because of the mesas which have been observed from space, and which shows that this is the area in details. It's not far. Isidis Planitia. You know, Isidis is well known also for its geology, and Utopia Planitia is a country, is an area where you have this is a very large area, and there has been a phenomenon of glaciation followed by volcanism, and volcanic dust covered the ice before it melted, and so the result is now that we have that kind of mesas, and we don't see ice, but the electricity shows that it has been very rich in ice, and and people think that under a cover of 1 meter to 2 meters regolith, there is still a lot of ice, and the area is covered with that kind of mesa, which are not also very high. It can be to 100 meters, and it is, as you see, the diameter, it can be 1 kilometer or so. So it's an interesting resource for water, but unfortunately the latitude is quite high. So Eborus and Hephaestus valles. These are much closer to the equator. The equator is here. It's much closer, and this is an area with a lot of sediments flowing from the higher grounds of the southern hemisphere, and also from the volcano Alba Patera here. No, Elysium. And so there is a lot of underground water channel which has been made by flow of water, and these they created tunnels, and we have apertures which allow to go to inside these tunnels. And people think that there could still be a lot of water underneath. Well, this is another view of it. Another view of it, which shows it's a karstic relief, and it shows that, well, hopefully there is some water underground, but that we don't know, but it's a possibility, and so this could be interesting. And this is another picture of it, and you see all these are entrance to this network of subterranean tunnels. This is a close-up of one of these, and you see there is no. It collapsed. The ground collapsed. There is nothing around. It's not a meteor impact. It's really a collapsing of the ground, which created that. And this is 200 meters wide. Okay, so this is also very interesting because it's Hellas. As you know, Hellas is the deepest place on Mars. This is where we go down to 8,200 meters. And this is the deepest of the deepest place on Mars. On Mars, it's called the Badwater crater. You see? Badwater crater. This is 8,200 meters under the datum. Of course, people, well, it's unfortunately the altitude is not very interesting, but the depths can compensate because here we have an atmosphere which is double what we have at the datum, and that might allow water to be a few degrees between freezing and boiling point, that is maybe 3-4 degrees. So there might be some liquid running water. This is the place. I doubt, of course, that planetary protection authorities would allow people to land there. But anyway, it would be interesting. Maybe they could land here and go down to sea. And the last one, which is my favorite, it's Medusae, here, Medusae fossae. And because, well, it's not very low. It's, you see, in the 2,000 meters, maybe, minus 2,000 meters, minus 1,500. But it's very close to interesting places. And you have these, I can see, yes, here the detail. You see, you have these long, long mounds, which are almost certainly made of ice. And since we could land anywhere in between and have access to this, and it is almost on the equator. So this is really, it might be the very best area to land. That's a crater in the area where you see the mud, that the mud have spoiled out at the impact. Well, this is it. And now if you have some question.
Questions?
Just a for additional interest, there is a paper from 2021 with SpaceX engineers and JPL doing an analysis of landing sites, which I think is where the Arcadia pollution comes from. And they give some detail about why it was selected, which includes they did some radar analysis of water ice.
Arcadia?
Yeah, they choose Arcadia and Erebus Montes as well. So there's that region.
Yes.
They give you a number of candidate sites.
Yes, but nowadays we found water in several places. So it's better to choose water on the equator than water up north. And of course, there is also in the south there is an uncertainty which maybe the new ESA mission will help us to solve. Is that they will maybe give us how much protection we can obtain from the magnetic field, the residual magnetic fields, which are very numerous in the southern hemisphere. Well, we don't know yet. We know that there is such residual magnetic fields, but we don't know how dynamic they are, how powerful they are, and if they give some safety additional to the thickness of the atmosphere. Okay, thank you.
I have a question.
Ah.
Yes, if we are thinking about, let's say, thousands of people, is this still the best place, Medusa Fessae, or what is the best place for, if we imagine, what about millions of inhabitants?
I think the most important is accessibility, is water accessibility. And also the equator, because the equator you don't spend so much energy. Or at some period of the year, if you are 20 degrees south, you have to very long night and very cold night, and you have the austral winter, which is dreadful. So you have to be close to the equator, and you have to be close to an ice deposit. I would say this is the most important, because otherwise, flatness, we will certainly improve the way to go to Mars, and will can remediate. And depth, of course, is interesting for the coverage of the radiation. That is, in any case, we would not go to the volcano. We would not go to the Tarsis volcanoes because they are too high. Altitude is too high, and So I think, in the order, I would say water, then equator, then. Altitude, and last one.
What about other resources, perhaps?
Well, yes, but resources we can get. Of course, we don't have. USGS has produced a map with mineral resources. We know that from of course from the satellites, and we don't know that very well, but we know more or less. But what I think is that people on Mars will use the huge deposit of sands and of dust, because this in the dust you have all the minerals of the planet, by definition, because the wind carries everything around the planet. And in the sun, in the sand, you have all the local minerals. So I think this would be the easiest way to make an industry, to make transformation of raw materials, to use this, which doesn't need to be extracted with heavy means, and maybe we would start with that. So I would not say to go to the most dusty place, of course, but dust and sand will be. And of course, if we want some specific minerals like uranium or gold or whatever, then we'll have to find them and mine them. But since water work has not been very long on the planet, I don't think there are many concentration of minerals, of metals or of minerals. Okay.
Thank you once again.
Merci.